function, and this is a point. I'm going to call it A, and I'm going to say that the x coordinate is x, and you'll tell me the y coordinate. There is no thinking required. The y coordinate is, say yes, or there is another way of writing y. F of x, awesome. Let's suppose there is, this is a function that, let's say, is the cost function. We are manufacturing whatever you want. We're manufacturing a product, and let's say we get a phone call this morning that says, by the way, the raw material doesn't cost $3 anymore, but it's $3.10. So I'm going to say it's a minor change in the input, right, in the cost of the raw material, right? Agreed? So from X, $3, $3.10 will be very close, but I want to illustrate what I'm doing, so I'm going to put it here. But it's very, very close. So I'm going to say this is X plus a little bit. Normally in calculus and pre-calculus, a little bit is denoted by little h. So that h is 0.10 cents. So now this is point B. I tell the manager of the factory or to ourselves, okay, let's see now how much will that trigger in the final cost of the raw material. So we know whether we have to increase the price or do whatever. Okay, so what is this then? Awesome. Perfect. So the idea then, one more time, is for a small change in X, I want to know what is the change in Y. For a small change in the input, I want to see what is the change in the output. This is nothing else but the slope of this line. Nothing else. The rate of change. So this is a line passing through A and B. And this is the slope of that line. This will give us the rate of change of Y for a small change in X, triggered by a change in X. So can anyone give us the slope? Is it your notebook or your phone?
I'm just getting something so I can draw a line. Card.
Okay.
So we go using the slope formula.
There is only one. I can't invent another.
Okay, we'll let someone else.
I would be getting a big prize if I would be able to invent another. There is only one. What is it?
Y2 minus Y1.
Awesome. Good. Can anyone dictate?
F1x minus h. Or sorry, x plus h in the parentheses.
Y2. What is Y2?
F1x plus h.
Oh, you said F1. Okay. F of x plus h. I'm sorry.
Minus.
Yes.
F of x.
Awesome.
Over.
Yes?
Over x. I mean x plus h.
Awesome.
Minus x.
Very good. Y2 minus 1 over x2 minus x1. f of x plus h minus f of x over x plus h minus x. What happens now? Look at this expression and say, I know what happens. What?
What?
When you look at this, what will you do immediately without even thinking?
X is moved from that.
Right, of course. So then the simplified form is f of x plus h minus f of x divided by h. This is so important that it has a special name. It's called the difference quotient. That's another one for our little notebook. Super important terminology. Good. So now, give me any function you want. It can be quadratic, it can be radical, it can be rational, any function you can think of. Okay, 2x minus 1 over x plus 3. What type of function is this?
Rational expression.
Awesome. Rational function. Very good. It is also a rational expression. You're correct. No mistake there. It is a rational function. And I'm going to ask you, so I'm going to abbreviate difference quotient dq. I want you to find dq for this function. I will copy the expression, which is the difference quotient, f of x plus h, minus f of x divided by h. And I'll make it wait for me for a moment because I claim that I have two pieces of this, but I don't have the third piece. Which pieces I have and which pieces I don't. Which pieces I have and which piece I don't.
F of x.
Of course. I can't do anything to that. Awesome. That I have.
You don't have h.
H is just a little 10 cents. I can't do anything to it. So what is the one that I don't have yet?
X plus h.
Right. So before we determine that, let me tell you what I see when I look at this function. Let's say you give me this function and you say, tell me what you see. And I will tell you this. When I look at this, I see this. F of whatever equals 2 times whatever minus 1 over whatever plus 3. This is what I see. Which means that if you want me to find f of x plus h, then I know what to do. But I have to interpret the pattern. Once I understand the pattern, I can determine whatever you asked me to do, to determine. So the pattern is 2 times blah minus 1 over blah plus 3. And now I have to find f of x plus h. This is that $3.10 that I have to plug in everywhere. That, of course, I don't have. And I don't care. So this becomes 2x plus 2h minus 1 over x plus h plus 3. Of course, here I have to understand parentheses. There is no other way. And now I have all three pieces. I have determined the first piece. The function was given to me. And h is just that 10 cents. I can't change that. I can't do anything to it. So now I can put all three pieces together, simplify the top, blah, blah, blah. Okay, what has to happen here before we even touch it? What has to happen is the h in the denominator must go away. but I can't erase it. It must go away with something from the top that will be an h, and then I simplify. If I don't get to that stage, when I simplify this h, in the final answer, I may still have h in there. That's fine. But if the h in the denominator does not go away with the factor from the top in all dq's forever, then something is wrong. So this piece must go away with something from the top on all functions forever whenever you determine the difference quotient. Ready? So now let's put everything together and see what happens. A long fraction line. I copy 2x plus 2h minus 1 over x plus h plus 3 minus 2x minus 1 over x plus 3 divided by h. Before we continue, I want to draw your attention to one thing. Can anyone tell us which function was used for this difference quotient? It's right here.
1 over x.
Right? Because this is f of x plus h. This is 1 over x squared, the function, and when you replace x by x plus h, you get this. So this is the difference quotient for 1 over x squared. Okay.
That's the same way.
Of course. What is the function that was used here?
X plus 5.
X over x plus 5. Why? Because when I replace x by x plus h, I get this. And the denominator is h. If the denominator is h plus 1, that's not a difference quotient. Right? What about this one? 3 over x minus 4. Because when I replace x by x plus h, I get this. So all these, that's why I wanted to show you the background for all these three. They're all different functions, but they're all the difference quotient for these functions. Okay. Good. So now, and that's why I didn't say it last time. I don't know if I can find quickly. I don't want to waste your time. I hate wasting your time, especially in this class. But if you go back to the readiness quiz from Monday, look at the last problem. I don't want to waste your time. I'm hoping you have it. Look at the last problem and tell me what is that difference quotient on what?
Oh, yeah. X, what? Yeah. X squared. Over x squared.
Good. So now we know. Very good. What is the next step?
Lowest common denominator for the two fractions on top.
Absolutely. And the denominator is h or h over 1. Good. What is the least common denominator at the top?
X plus 3 times x plus 8.
Of course, they have nothing in common. These are two different factors. Very good. When the denominator, is this clear? Everyone?
Yeah.
Yes? Everyone? Okay. So when we multiply the denominator of the first fraction by this, we must do the same thing to the top. When we multiply x by plus 3 by this, we have to multiply the top by the same thing. Now I have to be very careful. I always run out of room, and you'll see that throughout the entire semester. So please dictate. We must distribute x to these three terms, and then distribute 3 to these three terms. Then distribute 2x with minus in front to these three terms, and -1 minus 1 to these three terms. I'm ready when you are.
squares for 2hx plus x.
One more. One more.
Minus
Or, oh, I wrote the wrong thing on my paper. Minus x.
Good. Then,
6x
yes?
plus 6h
Yes?
minus
Awesome. We're done with the top of the first. Correct? Okay, now careful. 2x times x with minus in front.
negative 2x squared.
Very good, awesome. 2x times h with minus in front.
Negative 2h.
Negative 2x.
xh.
Good. Negative 2x times positive 3.
Negative 6.
It's negative 6x. As you see, I already ran out of room. So now minus with minus will be positive, and I have to distribute. So positive x plus h plus 3. So please continue. I just didn't have room.
Good Lord.
Right. One more key here. If the terms at the top that do not have h do not go away, for any difference quotient, something is wrong. Only terms with h have to be left over, so I can pull out an h and eventually eliminate that h in the denominator with. So, all terms without h must go away. Maybe some terms with h will go away, that's fine too. But all terms without h must go away. 2x squared with negative 2x squared. Negative x with positive x. 6x with negative 6x. Negative 3 with positive 3. 2xh with negative 2xh. And look. We are only left with two terms. And as expected, we have 7h over x plus 3 times x plus h plus 3 multiplied by, how do I divide two fractions? Multiplied by 1 over h. So one more time, let me summarize those two key actions. One key action, everything that does not have h must go away. You cannot make it go away. It has to be legitimate, right? Positive and negative. Second thing, some of the terms with h, like it happened, negative 2xh with positive 2xh may go away as well. But all terms without h must go away. At the very end, we have to have only terms that have h. There may be 5 terms, 2 terms, 3 terms, 1. Doesn't matter, but they have to have h. Then when I change it into a multiplication, now as the final step, I will be simplifying h by h. Please write 1. If you don't write 1, you may think that it's 0, and you may write 0 over who knows what. So I recommend write 1 every time you simplify by the same quantity. So this is x plus 3, x plus h plus 3. As I mentioned before we even started, there may be, and it will be, an h left in the problem, but not the one that we had in the denominator. That one must go away. Any questions? And this happens for any function you work on. Questions? Any questions?
Need practice.
Say it again.
Says need practice.
A lot. Yes. Okay. So have you worked on, this is the 1.4 actually. Yes, I also mentioned this. And then I would like to go back to equations and inequalities. Please. Not this one though, because we did not get to trig yet.
Okay.
Do I pick? You pick?
what section is this?
This is on page 19 at the bottom. Page 19 in the big supplement
No, I have that. I was
at the
saying,
bottom.
you know offhand what section it is?
This one, in the book, it doesn't exist.
Oh.
Yep. It's not in the book. Ready? Which one? Bless you. Which one? Yeah, it's on high warm, but sometimes this corner room is freezing. So always have a jacket or something. Yeah. Blanket, anything. If you need to get up and stretch, please do so. It's a 2-hour and 10-minute class, so please do that. Okay, please.
About 6.
6 it is. You're responsible for the other ones. Please. Okay. The square root of 1 plus 2x minus 1 over 8x, everything squared. Okay, bear with me with my little joke, game, whatever you want to call it. Okay, I'm ready. One plus. How many terms will you give me?
3.
Awesome. Thank you. Thank you. First term squared, please.
4x.
Minus. Multiply the two terms and then multiply by 2. Write it down. You don't have to do it in your head. So you write 2x times 1 over 8x multiplied by 2. And tell me what you get. Four divided by 8, 1/2. X goes away. It's 1/2. Plus. Right? Multiply the tops. You get 4x. Multiply the bottom. You get 8x. Simplify 1/2. Are we in agreement?
Yep.
Good. Second term squared, please. Yes? Awesome. Very good. Let's combine like terms now. What will you write? And in descending order, please. Awesome.
Plus 1 over 64.
I have to put this first. Yes. And plus 1 over 64x squared. Awesome. Again, my little game. Okay. So what is this?
Oh,
Yes.
that's a thing. Alright, it's
Yes.
2x plus 1 over 8x.
Awesome. Awesome. Because it's the same thing. Look at this. This is this, but now here I only have plus. It's the same thing, but with plus.
Yeah.
Awesome. Final answer?
Yeah, 2x plus 1 over 8x because the square root.
However, it has to be an absolute value. Let me explain the absolute value, and then we go back to equations. So the square root of x squared is x, but only if x is greater than or equal to 0. But the square root of x squared is not x if x is less than 0, because the square root cannot be a negative number. So if x can be any real number, then the square root of x squared is the absolute value of x. Since here we had no indication that this was, the x could be positive or negative, we had to use the absolute value. However, don't change anything. If it happens that I have this, I'm going to erase it. Then everything is positive and I don't need the absolute value. This is positive, this is positive, this is positive. So this is redundant. But I don't have that. So I have to use the absolute value. Okay, any questions for me? Any questions? All of them are pretty similar. So I would like you to work on this as well. Okay, so now let's go back to the book and look at different types of equations. Paul, you're saying something?
Oh, I'm just making a note here.
Okay.
Thank you.
Good. Any type of equations that you think you may have difficulties with. For example, we looked at rational equations, radical equations, we have quadratic equations, we have absolute value equations. So tell me which part of all this I should go back to. Quadratic, linear, radical, absolute value. Equations quadratic in form. I want to show an example of quadratic in form till you make your decision. So what type of equations you think we should review from algebra? Linear, quadratic, we did rational, radical, absolute value, and I will do quadratic in form. Which one?
Go over absolute value again.
Yes. So let's say the absolute value of x plus 3 is 5. So the question is, what could I have here? So that the distance from that number and 0 is 5.
Right.
What could I have here?
5 or negative 5.
Awesome. So that's the answer. So x plus 3 could be 5, or x plus 3 could be negative 5. And I solve from there. Subtract 3. And subtract 3. These are the absolute value equations. Okay. So anything else? One more time. Linear, quadratic. This was absolute value. Rational we did last time. Quadratic in form. Radical. Yes.
For the quadratic in form.
Yes, I have to show that.
Oh, okay.
I have to show that. So here's a an equation that, yes. Say it again.
Do we do a quadratic?
You do quadratic? Oh, it's either you factor or quadratic formula. But it's going to be quadratic in form, so we're going to get to a quadratic equation. So quadratic in form. What does this mean? Is it quadratic or not? No, it's not quadratic. But it can be replaced by a quadratic equation with a particular substitution. It's not quadratic. But I can change it into quadratic using a substitution. I solve the quadratic and then I go back to the substitution. That's the theory behind it. So let's say 97 on page 55. 2x to the 4th plus 4x squared plus 1 equals 0. Is this quadratic? degree 4. How can it be quadratic? It cannot be quadratic. It's degree 4. Quadratic means degree 2, period. Degree 2, nothing else. Not 1, not 3, not 4. 2. So it's not quadratic. And why do I say it's quadratic in form? Because I look at these two, I see the smaller of the two exponents here, and I'll say, what if I denote this by y? Will this be y squared?
Yeah.
If it's not y squared, then it's not quadratic in form. But it is y squared, because if I square this, I get x to the 4th. So I already changed the equation into 2y squared plus 4y plus 1 equals 0. So it is quadratic in form because I used the particular substitution, which was x squared. I replaced x squared by y, and I changed it into a quadratic. And now let's practice the quadratic formula. How do we solve this? Using the quadratic formula. Y equals negative b plus or minus the square root of b squared minus 4ac over 2a. This is again good. So can anyone dictate?
A is 2, B is 4, C is 1.
Correct.
Negative 4.
Awesome. Plus or minus
Square root of 4 squared.
16
That's 4
times 2, which is 8.
1 to 8. Yep.
Over
2a, which is 4.
Awesome. That's all I needed. I forgot to ask from the beginning. Forgive me. I'm going to ask now. How many solutions will this equation have to have?
2 solutions. No. Which one?
The one we're solving.
4.
Yes. Degree 4, 4 solutions. Maybe 2 real, 2 imaginary, maybe 4 real. I don't know. But it has to have 4 solutions. Because the degree is 4. Good. So let's continue. So this is y equals negative 4 plus or minus the square root of 8, which is 2 the square root of 2. No, the square root of 8 is not 2, but 2 the square root of 2. Yes, I agree. Over 4. I will separate the solutions, the fraction or factor, whatever you want to do. This is one option, negative 4 over 4 plus or minus 2 the square root of 2 over 4. It will be a terrible mistake to simplify this with this or this with this. Because we said last time we simplify only, how are they called? And not the other one. 2 keywords. Notebook. We simplify only. Yes. Exactly. And 2 is not a factor. 4 is not a factor up here. 2 is not a factor up here. I can't do anything. We simplify only factors, comma, never what? Awesome. Very good. Now I can simplify. So this is negative 1 plus or minus the square root of 2 over 2. Is it done? No. We created a new variable. We are very proud of it. But we have to present the solution using the variable in the problem, not what we created. So now we have 2 equations to solve. Which equations?
Y equals negative 1 plus
Y is x squared.
and
X squared equals negative 1 plus the square root of 2 over 2
or, x squared
equals
negative 1 minus 2.
awesome.
So
How do I solve such equations? What are they, first of all? What type of equations are these now? Degree 2, we cannot think.
Quadratic.
Quadratic. Degree 2, quadratic. Good. How do I solve such an equation?
Get X to the other side.
Very good question. X is already on the other side, and everything else is on the other, right? So the terms without x on one side and x squared on the other. What is the best? We have 4 different methods, but which is the best method to apply here?
Would you do this?
The square root. Yeah. The square root. And remember, how many solutions will I get when I take the square root from x squared?
2.
Plus or minus. Very good. So then I have x equals plus or minus the square root of -1 plus the square root of 2 over 2. Now, is this a real number? No, it's not a real number. So it will be an imaginary or complex. Okay. What about the other one? Same procedure. Will this be a real number? No. I don't know how the book will present the solution. It may say no real solutions, which I will have to agree with, or it may say 4 complex solutions, which I will have to agree with. It turns out that this equation does not have real solutions. How do I know? So this ratio is smaller than -1. So this is the square of a negative number. So that's why it's a complex number. This is the sum of 2 negative numbers. It must be negative. So this is another square root applied to a negative number. So it cannot be real. Okay, I'd like to look at some inequalities. We have linear inequalities that we reviewed last time. We had an example. Are we okay with that? With linear inequalities. Okay. We have quadratic, polynomial, and rational inequalities and absolute value inequalities that we did not get the chance to review. So for 1.7, inequalities, linear, quadratic, absolute value, polynomial, which is higher than quadratic, rational. That's it.
This is things of practice.
This is the things that I would like you to choose from so I can illustrate.
Uh,
Anything you want. Rational, quadratic, polynomial, linear, absolute value. Please choose. What is not supposed to be reviewed is polynomial and rational. All these are from the previous course, but if you choose one, I will illustrate.
Rational.
Okay, let's illustrate with the rational. So here's an example of a rational. Let's say 66. 3 divided by x minus 1 minus 4 divided by x greater than or equal to 1. Okay? What is tempting here to do?
Start finding rules coming in on the
Yes. Good.
So
And
we
then,
have every term on one side.
yes, so you want to move everything to one side.
Right?
Awesome. Awesome. That's the key. 3 divided by x minus 1 minus 4 over x minus 1 greater than or equal to 0. Absolutely. Awesome. Thank you. Then,
you want to make the denominator
denominators equal?
Say it again.
You want to make the denominators equal? So it would be like x squared minus 1.
Yes, awesome suggestion. However, never multiply the factors in the denominator. Never multiply the factors in the denominator. We want them factored. Awesome. What is the LCD?
X times x minus 1.
Of course. Adjustments. Now I want it multiplied. Now I want it multiplied. Because then I have to multiply it and yeah. Good. Very good. The numerator, please. Yes.
Minus 4x minus 4.
Careful.
Plus.
Good.
Minus x squared plus x.
Awesome. This is not a trivial problem. I would never say that it's trivial. In descending order, please.
Negative x squared. Plus x. Less.
No. Yeah, cancel that. No.
Oh, I got it.
Yeah, that's cancel.
Plus.
Good. What would you do next? Because I can hardly wait to say no. Yes. Okay. Note. Never multiply both sides of an inequality by anything that has a variable in it, x or expressions with x. Never. Why? Can anyone say why? Why I'm not allowed to multiply by x times x minus 1? Or divide by x, or x minus 1, or x plus 2, or x plus 5. Why? Because x or x minus 1 could be, and then I have to switch the symbol, but I don't know. I have no clue. So I can't do it. Yes, Stephen?
Put 0 over 1 and
Yes.
then cross multiply.
It would mean the same thing. I can do it in an equation, but not in an inequality.
Okay.
So here is the next step. Yes. I love those charts, and I have in tables. I was taught this way. I'm not going to take credit for it. X is the variable in the problem. I have to, before I continue, I have to factor out -1 at the top. And then in parentheses, I have x squared minus 4 over x times x minus 1. And then how many times did I show this today? Okay, so then I will factor the numerator. So I have x with minus in front, minus 2, x plus 2 over x minus 1 greater than or equal to 0. Agreed?
Yes.
Because I want to eliminate this, because it's in the way, I will multiply both sides by -1. And then I have x minus 2, x plus 2, x minus 1 less than or equal to 0. Remember the two keywords that we always think of in algebra, in pre-calculus? Simplify factor, simplify factor, simplify factor. Yes, please.
So you just multiply the
The whole
left side
thing.
by negative and
The whole
right
thing.
side by negative.
Yeah, because this negative can be brought here.
Okay.
Good. So I have 1, 2, 3, 4 factors in the problem. X is the variable in the problem. First factor is x minus 2. Second one is x plus 2. Next one is x. Next one is x minus 1. And the last one is the whole thing. X minus 2, x plus 2 over x times x minus 1. Okay? X is the variable in the problem, goes from negative infinity to infinity. And now I need you to tell me, when is the first factor 0? When is the first factor 0? So the first factor is 0 at 2. Where is the second factor 0? At negative 2. Where is the next factor 0?
0.
When is the last factor 0?
1.
1. I want you to give me these numbers, of course, in which order?
Those ties.
Yes, ascending order. So what is the first number?
Negative 2.
Good. What is the next number?
1.
0. What is the next number?
1.
What is the last one? Good. So follow me, please. I need a 0 in the first row. Under which number will I put the 0?
2.
Thank you. I need a 0 in the second row.
Negative 2.
Awesome. I need a 0 in the next row.
0.
Awesome. And of course, I need a 0 in the last row.
1.
Perfect. Now I'm looking at the whole thing. This is the whole thing. When will this be 0?
X is 0.
No, it will be undefined then. A fraction is 0. A notebook. A fraction is 0 only when
Numerator.
the numerator is 0. A fraction is undefined only when.
The denominator is 0.
So, when will this be 0 then?
X is 2 or negative.
Awesome. When will this be undefined? At 1 or 0. I don't have a number. It's just a bar. I'm studying the sign of this. So how does x minus 2 look like when you want to graph it? Does it look like this with a positive slope?
Yes.
Or it looks like this with a negative slope?
Positive.
Good. So if it looks like this, it comes from which values? What type of values it's coming from?
Negative.
And it goes to which type of values?
Positive.
All of them have the same pattern. Because they all have a positive leading coefficient. How many subintervals I have? Yes. On the first subinterval, I multiply or divide 4 negatives. The sign is? You told me last time, negative x to the 4th power is?
So negative.
I multiply negative by negative by negative by negative. How can that be negative?
Positive.
Good. In the next subinterval, I have 3 negatives. If I multiply or divide, it makes no difference.
Yeah. Negative.
In the next subinterval, I have 2 negatives. Multiply or divide.
Negative.
In the next subinterval, I have 1 negative. And in the last one, I have no negatives.
Positive.
Which sign do I pick? Which sign is less than or equal to 0?
Negatives.
Right. Is this expression ever negative?
In 2 places.
In 2 places. When x is between
Negative 2 and 0.
union
Yeah. 1, 2.
So solution, x in the interval, -2, 0, union 1, 2. I intentionally did not write what. So I would like you to tell me whether I put a bracket or a parenthesis at -2.
Can I see this? It's I say parentheses, right? Because
It's 0, and 0 is included, so it's possible. So I cannot use parenthesis.
bracket.
About 0, at 0, what do I put? A parenthesis or a bracket?
Parentheses,
Why?
because 0 makes it undefined.
Exactly. Awesome. At 1,
Same thing.
right, because it makes it undefined. And at 2,
Bracket.
right, because it makes it 0 and it can be 0. Okay, we have 15 minutes. Open notes, open book, but not your neighbors. So Cheyenne, you have to leave some room. We have 15 minutes to work on this.